This presentation is about photodynamic therapy. If you think you know about photodynamic therapy, you probably need to forget everything that you think you've learned because it does not apply to what we're about to discuss. If you look up photodynamic therapy on the internet, you'll find all sorts of limitations. Can't treat anything more than 0.5 millimeters in size. Can't treat anything more than 1 centimeter into the body. Requires weeks or months of no sunlight. None of those things apply to the 4th generation photodynamic therapy that we're going to discuss today. We're going to discuss the application of photosensitizers. Those are chemicals that go into the body, and if they're properly designed, they go only to unhealthy tissue. We're going to discuss how those can be used for treating cancer, viral disease, bacterial disease, and autoimmune disorders. So how does it work? Well, on the surface, it's fairly simple. You put a photosensitizer into the body. If it's properly designed, it goes just to the bad cells. And then you use a laser or alternatively an LED if it's properly designed. And that activates the photosensitizer. When it's activated, it becomes extremely toxic. On its own, it's not toxic at all. It's completely harmless. As a matter of fact, what we use is classified as a food coloring. This technology can be used to control the most deadly of bacteria, methicillin-resistant Staphylococcus aureus, that cannot be stopped many times and requires amputations, can be stopped in about 15 minutes with this. Pseudomonas, that kills many people. It's easy to control these with PDT. So what are the primary components of this? Well, first you need a sensitizer. This is where everyone else fails. They're using sensitizers that are activated by the wrong wavelength of light. They don't go selectively into bad tissue. They go into healthy tissue. They localize in the skin. They cause you to be extremely sensitive to sunlight or even incandescent lights. When you're using these older style sensitizers, all of the limits you read about on the internet apply. They do not apply to what we do. Our sensitizer is different. We'll discuss that later on. Then you also need a laser. Now, some people are trying to do this with LEDs. Theoretically, it's possible, but everyone that I'm aware of in the world, and I think I know everyone in the world that's actually doing this, is using an LED system that's either the wrong wavelength, or it doesn't have enough power, or it's not focused properly, and it's ineffective. We use lasers that are custom designed for the purpose, and they can penetrate all the way through the bone. They can penetrate deep inside the body. They're completely harmless on their own. As a matter of fact, they actually have a healing effect on their own. They don't get hot on their own. So, what happens when you combine the two? Well, that's where it gets very interesting. When the sensitizer is hit by the exact right wavelength of light, it absorbs energy and it converts the oxygen that's in that area into a reactive oxygen, very, very toxic. That destroys the cell. This applies to cancer, bacteria, viruses, and immune cells that are out of order and behaving in a destructive fashion. The problem with most people's operations is they're simply not designed properly. So in the next segment, we'll discuss how this has to be designed to work as well as ours does.